Hi students, now we are going to discuss about changes around us. Changes around us. How it is happening? And then we see the number of changes in our surrounding. Some of them are physical change, some of them are chemical change. Physical change and chemical change. Physical change. Physical change. Another one, chemical change. Chemical change. Physical change, then chemical change. What is meaning of physical change? Physical change. What is meaning of physical change? The reaction in which no new products are formed known as a physical change. For example, melting of ice. Melting of ice. Melting of ice. Ice can be converted into water. Ice can be converted into water. What is the formula of ice? H2O. What is the formula of water? H2. In this reaction, no new products are formed because of the reactants are water molecule. The products also contain water molecule. So, the reaction in which no new products are formed known as a physical change. Physical change, physical state only change. One solid substance can be converted into liquid substance, that's enough. No new products are formed. Another one, folding, unfolding of paper. Folding and unfolding. Unfolding of paper. Folding, unfolding of paper. Then, drying of wet cloth. Drying of wet cloth. Then, bending of iron rod. Bending of iron rod. It is an example of physical change. Physical change. Two types of changes are there in our surrounding. One is a physical change and one is a chemical change. Physical change in which no new products are formed. For example, melting of ice, folding, unfolding of paper, drying of wet cloth, bending of iron rod. Ice can be converted to water molecule. Ice melted to form of water. What is the formula of ice? H2O. What is the formula of water? Also H2O. So no new products are formed known as a physical change. Another one, chemical change. The reaction in which new products are formed. Number of reactions are there. The reaction in which new products are formed known as chemical change. For example, burning of paper. Then digestion of food. Digestion of food material in our stomach. Another one, turning of milk converted into curd. Milk to curd. Then decaying of vegetables. Decaying of vegetables. Sodium chloride, NaCl in water. H2O. Sodium chloride, that means called a table salt. Sodium chloride dissolved in water. Then rusting of iron. Iron metal come in contact with the air, moisture, water vapor, dust particle to produce the then brown powder layer of ferroferric oxide, Fe2O3 dot X moles of water molecule. X moles of water molecule. Sometimes 2 moles, 3 moles and 5 moles are there. In the ferroferric oxide, ferric oxide, Fe2O3, ferric oxide. The ferric oxide combined with the water molecule to form of a rust. So formation of rust formed on the surface of the iron sheet. It is a chemical change reaction. Then sodium chloride. Then salt. Sodium chloride dissolved in water to form of sodium hydroxide and hydrochloric acid. Decaying of vegetable. Vegetables dissociated to form of a rancid. Then turning of milk into curd. Turning of or changes of milk can be changes into curd by using of in the lactase enzyme, enzymatic catalytic reaction. Digestion of food material in our stomach. In our stomach contain trypsin and pepsin liquid is easily destroyed the food material. In this reaction is an example of enzymatic catalytic reaction, because of the enzyme can be obtained from the combination of amino acids. So amino acid can combine to form of protein. Less number of protein to form of a peptides. Large number of protein continues to form of a enzyme. The enzyme used as a catalyst in the biochemical reaction. Digestion of food is one of the biochemical reactions. Another one, burning of paper. Burning of paper. The paper burn in air to produce the heat and light. It is an example of chemical changes. So two type of changes. One is a physical change, another one is a chemical change. Physical change in which no new products are formed. Chemical change in which new product, new substance, new compounds are formed from the reactant. What is the example of a physical change? So melting of ice, ice can be converted to water molecule. Folding, unfolding of paper, drying of wet cloth, bending of iron rod. It is an example of a physical change. Burning of paper, digestion of food material in presence of enzymatic catalytic reaction, turning of milk into curd by using of a lactase enzyme. In the taking of vegetables converted into vegetable can be converted into rancid. Another one, sodium chloride dissolved in water to form of sodium hydroxide. In then iron metal come in contact with the air, moisture, water particles to form of a hydrated ferric oxide known as rust. It is an example of physical chemical changes. So what is meaning of physical change? The reaction in which no new products are formed known as physical change. What is meaning of chemical change? The reaction in which new product, new substance, new compounds can be obtained from the reactant known as in the physical chemical change. From this lesson or from this topic, we will learn about what is meant by chemical change, what are the factors it is used to indicate the chemical reactions. What are the factors it is used to determine the chemical reactions? Okay, next one. Chemical change. What is meaning of chemical change? Chemical change is permanent and irreversible reaction. Permanent change. Permanent and irreversible. Irreversible reactions. What is meaning of permanent? Permanently to form a product. What is meaning of irreversible? Two types of reversible reactions are there. Two types of reactions are there. One is a reversible and one is a irreversible. Reversible and one is irreversible. What is meaning of reversible? The reactant can be converted into product recombined to form of original reactant known as a reversible. Reversible. For example, hydrogen can combine with the chlorine to form of hydrogen chloride, HCl, hydrochloric acid. H2 hydrogen, Cl2 chlorine. The hydrogen can combine with the chlorine to form of hydrochloric acid. The hydrochloric acid again decomposes to form of a original reactant of H2 and Cl2 by using of double arrow. One is a forward arrow, another one is a backward arrow. Forward arrow indicate the reactant can be converted into product. Backward arrow indicate the product again recombine to form of original reactant. The process known as a reversible process. Reactant can be converted to product again recombine to form of original reactant known as a reversible process, reversible reaction. What is meaning of irreversible? Irreversible. The reactant only can be converted into product. For example, calcium carbonate CaCO3 is a decomposed form of calcium oxide plus carbon dioxide. Calcium carbonate. So calcium carbonate, limestone. Calcium carbonate otherwise called a limestone. Calcium carbonate decomposed form of calcium oxide and carbon dioxide. The calcium oxide cannot be recombined to form of original reactant of calcium carbonate. That's why this reaction, irreversible reaction, maximum chemical reactions are irreversible process. So simply chemical reaction can be defined as chemical reaction is a permanent and irreversible reaction which can be converted into product. Chemical change otherwise called a chemical reaction because of one or more reactant react with each other to form a product. The reactant can be converted into product. Reactant can be converted into product. Reactant can be converted into product. Zinc carbonate or the zinc metal burn in air to produce zinc carbonate, zinc oxide, Zn O. Hydrogen elements H2 can combine with oxygen O2 to form of a H2O water molecule. Hydrogen gas H2 combine with nitrogen gas N2 to form of ammonia NH3. Hydrogen gas H2 can combine with I2 iodine gas I2 to form of hydrogen iodide HI. Carbon burn in air to produce the carbon dioxide. It is a simple chemical reaction. So chemical reaction is a permanent and irreversible, which can be converted into product. Chemical changes are always called chemical reactions because of one or more reactant react with each other to produce the product. Zinc burn in air to form a zinc oxide. Hydrogen combine with oxygen to form of water molecule. Hydrogen combine with nitrogen to form of ammonia. Hydrogen combine with iodine to form of hydrogen iodide. Carbon burn in air to produce carbon dioxide. Magnesium burn in air to produce magnesium oxide. Hydrogen combine with bromine to form of hydrogen bromide. Hydrogen combine with fluorine to form of hydrogen fluoride. In the decomposition of a number of reactions are there. In the all reactions are chemical reaction. Chemical changes takes place because of then one or more reactant react with each other to produce the product. It is a chemical reactions. Next one. Now we are going to discuss about what are the factors to determine the chemical changes. To determine the chemical changes. What are the factors? What are the factors? What are the factors to determine the chemical change? Chemical change. What are the factors to determine the chemical changes? The factor to determine the chemical changes. First one, because of in the chemical changes reaction do not takes place in all condition. Chemical changes takes place certain specific condition. The chemical reactions are takes place in certain condition in the following order. One is a contact in physical state. Contact in physical state. The next one, solution of reactant. Next one, electricity. Then heat. Then light. The last one, catalyst. Catalyst is a chemical substance. It is used to initiate the rate of reaction. Alter the rate of reaction, speed up the equilibrium concentration. Catalyst is one of the chemical substance. Do not react with the reactant. Another also light. The chemical reaction takes place in presence of a photoelectric light known as a photochemical reaction, otherwise called photolysis. Then heat. Heat can be measured in terms of temperature. Temperature is one of the parameter. It is used to increase the rate of reaction. Maximum chemical reaction takes place in increase in temperature. So the chemical reaction takes place in presence of temperature or increase in temperature known as a thermochemical reaction, otherwise called thermolysis. Electricity. Do you know the number of chemical reaction takes place by passing electricity in industrial process? So chemical reaction takes place by using of electricity or electric current known as a electrochemical reaction or electrolysis. Solution of reactants. Maximum most of the chemical reaction takes place in the form of solution. But if we are take in the reactant or one or more reactants are takes place as a solid state, means in the chemical reaction do not takes place. Then solid substance dissolved in any other solvent to form of solution. The solution react with each other to form of a product. So solution of a reactant, maximum chemical reaction takes place in the form of solution. Another one, contact in physical state. Physical state can be changes into form of a product known as a contact in physical state. Try wood burn in air to produce heat, light and smoke. It is one example of contact in physical state. Then painting of a matchstick pen is rubbed on the surface of the matchbox. So to produce heat, light and energy and smoke is a contact in physical state. It is a factor to determine the chemical changes. So now we are going to discuss about step by step in what are the factors determine the chemical changes reactions. Then first point, and then factor to determine the chemical change. In first point, contact in physical state. For example, in the burning of matchstick when rubbed on the surface of the matchbox to produce the heat, light and energy. Then try wood burn in air to produce heat, light and smoke. Then calcium oxide, that means called quicklime. Calcium oxide, quicklime formula calcium oxide, CaO. So dissolved in water, H2O, to produce calcium hydroxide, CaOH twice. It is a slacked line. Calcium oxide quicklime, calcium hydroxide slacked line. Calcium oxide dissolved in water to produce calcium hydroxide. Quicklime dissolved in water to produce slacked lime. It is an example of contact in physical state. Contact in physical state is a physical changes reaction. So physical state changes. Solid can be converted to liquid. Liquid can be converted to gas. Or solid directly converted to gas without liquid. Solid converted into liquid. Or liquid can be converted into gas. Or gas can be converted into, or then solid can be converted into gas. Solid can be converted into liquid known as smelting, fusion. Liquid can be converted to gas known as evaporation. Solid can be converted to gas known as sublimation, without liquid, sublimation. Liquid can be converted to solid, freezing. Gas can be converted to liquid, condensation. Gas can be converted to solid, also condensation. The process takes place in the changes of physical state, physical changes. Solid can be converted to liquid can be converted to physical state only changes known as a physical state. A contact in physical state, burning of matchstick when rubbed on the surface of the matchbox to produce the heat and light known as in the physical changes reaction. Try wood burn in air to produce heat, light and smoke. It is a physical changes reaction. Another one, calcium oxide dissolved in water to produce calcium hydroxide. Quicklime dissolved in water to produce calcium hydroxide known as physical changes reactions. Next one, second one, in the solution of reactant. Solution of reactants. When milk mixed with coffee decoction, in the color of both coffee decoction and milk changes due to chemical reactions. Maximum or most of the chemical reaction takes place in the form of a solution. For example, silver nitrate, AgNO3, silver nitrate, is a react with sodium chloride, NaCl. Solid form of silver nitrate react with the solid form of sodium chloride, no reaction takes place. Solid silver nitrate, solid sodium chloride do not react with each other. However, silver nitrate dissolved in water to form a silver nitrate solution. Silver nitrate dissolved in water to form silver nitrate solution, AgNO3 solution, silver nitrate solution. The silver nitrate solution takes in a small test tube. Sodium chloride, NaCl, sodium chloride, solid substance. Silver nitrate, solid substance. Dissolved in water, H2O, to form of in the sodium chloride, NaCl solution. Then sodium chloride solution takes place in another test tube. The two test tube contain silver nitrate and sodium chloride mixed with each other to produce a new substance of new compound, new product of silver chloride precipitate and sodium nitrate can be removed. So silver nitrate, AgNO3 solution mixed with sodium chloride, NaCl solution to form silver chloride precipitate AgCl, white precipitate plus sodium nitrate NaNO3 removed. Sodium nitrate can be removed. Solid form of silver nitrate, solid form of sodium chloride do not react with each other. No new products are formed. Silver nitrate is dissolved in water or aqua solution or any other solvent to produce silver nitrate solution. The silver nitrate solution takes place in one test tube. Then sodium chloride dissolved in water to form of sodium chloride solution. Sodium chloride solution takes place in another test tube. The two test tubes contain a silver nitrate and sodium chloride mixed with each other. Solid form of silver nitrate and sodium chlorides do not react with each other. Solution form of silver nitrate and sodium chlorides react with each other to produce new substance of silver chloride and sodium nitrate. So new substance of silver chloride can be obtained from silver nitrate solution and sodium chloride solution. From this reaction, we can conclude that most of the chemical reaction takes place in the form of solution. Solid form of reactant do not react with each other. It is explained by in the solution of a reactant. It is also one of the factors to determine the chemical changes, chemical reactions. Another one, electricity. Electricity is essential for our life. We use the electricity in grinding, mixing, watching television, watching the mobile, then watching any other videos. Do you know, electricity is also used to carry out the number of chemical reaction in industrial process. In industrial chemical process, the electricity is used out the number of chemical reaction, carried out the number of chemical reactions. Do you know, in the water molecule can be obtained from H2O can be obtained from combination of hydrogen and oxygen. As you know, hydrogen can combine with oxygen to form of water. What is the formula of water? H2O. What is the formula of hydrogen? H2. What is the formula of oxygen? O2. So, in the water molecule can be obtained from or made up of hydrogen can combine with oxygen. Electric current is passed through water in presence of concentrated sulfuric acid. The water molecule dissociate hydrogen plus oxygen. In this reaction, the reactant can be converted to product. So formation of water molecule, the water molecule can be obtained from combination of hydrogen and oxygen. But here, electric current passes through the water in the process known as the electrolysis process. Electrolysis of water molecule or electric current passes through the water molecule to produce or dissociate to form of hydrogen and oxygen. The process known as a electrochemical reaction or electrolysis process. The electrochemical reaction or electrolysis process always takes place in the form of electricity. So chemical reaction takes place or chemical reaction carried out in presence of electric current known as a electrochemical reaction or electrolysis process. Another one, brine solution. Concentrated solution of sodium chloride in water known as a brine solution. Brine solution. What is meaning of a brine solution? Concentrated solution of sodium chloride in water. Sodium chloride. What is the formula of sodium chloride? NaCl. Sodium chloride. What is the formula of water? H2O. Sodium chloride is salt. Sodium chloride is dissolved in water molecule to produce in the sodium hydroxide NaOH plus in the hydrochloric acid HCl. By using of electric current, electricity, electric current passes through in the brine solution of sodium chloride in water to produce sodium hydroxide and hydrochloric acid. Hydrochloric acid HCl. The hydrochloric acid HCl dissociate to form of H plus Cl minus ion. The Cl minus ion contains extra electrons. The extra electrons of Cl minus ion can combine with each other to form of Cl2 and 2 electrons are lost. That 2 electron can be accepted by 2H plus to form of hydrogen gas. So concentrated solution of sodium chloride in water known as a brine solution by using of electric current or the electric current passes through the brine solution of sodium chloride in water to form of sodium hydroxide and hydrochloric acid. The hydrochloric acid dissociates form of chlorine and hydrogen. The process also carried out in in the what carried out in a electricity process or carried out in presence of electricity or electric current passes through the brain solution to produce the sodium hydroxide, hydrogen and chlorine. So from this reaction we can conclude that in the number of reaction takes place in industrial process, in a laboratory process, in the to form of new product by using of electric current known as electrochemical reaction or electrolysis process, the reaction in which chemical reaction in which it takes place are carried out under the electricity or electric current known as electrochemical reaction or electrolysis process. Next topic, heat. The heat is measured in terms of temperature. Temperature is one of the parameters. It is used to increase the rate of reaction. Number of chemical reaction takes place in presence of temperature. For example, zinc metal burn in air to produce zinc oxide, ZnO, heated 773 Kelvin, temperature 773 Kelvin. Then calcium oxide, then zinc or calcium, magnesium, any other metals combine with the air to form of a metal oxide in heating. So temperature increases, rate of reaction also increases. When lead nitrate, BbNO3, what is the formula of lead nitrate? PbNO3. What is the formula of symbol? What is the symbol of lead? Pb, plumbum. Latin word of lead is a plumbum. Nitrate NO3. The two indicate the valency of metal. That's why NO3 twice. So what is the formula of lead nitrate? PbNO3. The PbNO3 heated, you will hear the cracking sound because of lead nitrate decomposed to form of lead oxide PbO and reddish brown gas RB, reddish brown gas. Reddish brown gas, nitrogen dioxide are evolved. Nitrogen dioxide is evolved. So lead nitrate is a decomposed plus oxygen gas. Lead nitrate is a decomposition of lead nitrate by using of heat or by using of temperature. Lead nitrate is small, it is one of the experiment. The small amount of the lead nitrate is taken in test tube. In the heated gently on the Bunsen flame. In then what? You will hear the cracking sound, tap tap tap, and cracking sound formed from the decomposition of lead nitrate because of reddish brown gas. Nitrogen dioxide can be evolved. This reaction takes place in temperature. Then zinc carbonate, ZnCO3, that means called calamine. The calamine heated 300 degrees Celsius to form of zinc oxide plus carbon dioxide. Limestone, calcium carbonate, CaCO3 is heated at certain temperature. The heating temperature can be indicated by triangle. The triangle is used to find out the or used to indicate the some amount of temperature it is used to decompose the or some amount of temperature it is used to convert the reactant can be converted to product. Calcium carbonate, limestone. The limestone decomposed to form of calcium oxide plus carbon dioxide. Calcium oxide and carbon dioxide. It is an example of by using of heat can be converted the reactant to product. Heat is one of the important parameter. That parameter it is used to increase the rate of reaction. It is used to increase the rate of reaction. Maximum most of the chemical reaction takes place in presence of temperature. Here, for example, zinc metal burn in air to produce the zinc oxide in presence of in the temperature 773 Kelvin. Lead nitrate decomposed to form of lead oxide and nitrogen dioxide plus oxygen gas. Nitrogen dioxide is a reddish brown gas. Zinc carbonate heated 300 degrees Celsius to form of zinc oxide. Zinc carbonate, zinc oxide to form of carbon dioxide. Calcium carbonate, CaCO3, limestone, otherwise called limestone, heated at certain temperature to form of calcium oxide and carbon dioxide. Another one, light. By using of light, in the main source of light is a sun. Sun is the main source of light. In the sunlight can be used for photosynthesis reaction. Without photosynthesis reaction, then living things cannot live in the world. Then sun photosynthesis. What is the meaning of photo? Photo means light. Synthesis meaning production, produce. new compounds, new substances are produced, new compounds are formed. Synthesis means new compounds are formed. Photo means light. By using of light energy, the reactant can be converted into product, new product. One or more new substances are formed known as a photosynthesis process. Not only photosynthesis process, number of chemical reaction takes place in presence of light. In presence of light. Even for example, 6 moles of carbon dioxide CO2 can combine with the atmospheric moisture of 6 moles of water molecule in presence of sunlight to form of starch C6H12O6. C6H12O6 starch plus along with the oxygen gases are removed. Oxygen gas can be removed. The process known as a photosynthesis process. In photosynthesis process always takes place in a green plants of pigments contained in the sunlight used as a light sensitizer. In the atmospheric carbon dioxide can combine with atmospheric moisture to form of in the starch or glucose or fructose is always stored in the form of in the carbohydrate in plants and oxygen gas are removed. Then hydrogen gas H2 can combine with chlorine Cl2 in presence of H nu to form of hydrochloric acid HCl. In the hydrogen gas can combine with the chlorine gas to form of hydrochloric acid. In this reaction also takes place in presence of photoelectrons. H is a Planck constant. The Planck constant which is equal to 6.626 in 10 power minus 34 kilogram meter square per second. Mu is the frequency of radiations. So Planck constant can combine with the frequency of radiation gives you some kind of a photoelectrons. That photoelectrons it can be used for the conversion of hydrogen chlorine can be converted into hydrochloric acids. In the chemical from this reaction we can conclude that the chemical reaction takes place in presence of light known as a photolysis process or photochemical reactions. In this reaction, the chemical reaction in which takes place in presence of temperature or heat known as a thermochemical reaction, thermolysis process. The reaction in which are carried out in presence of electric current known as a electrochemical reaction or electrolysis process. So by using of electric current means electrochemical reaction, electrolysis process. By using of temperature means thermolysis process, thermochemical reaction. By using of light means in the photochemical reaction or otherwise called photolysis. Photolysis otherwise called photochemical reaction. Electrolysis otherwise called electrochemical reaction. Thermolysis otherwise called thermochemical reaction. And the last one, catalyst. Important topic. Catalyst. Catalyst. What is the meaning of catalyst? Catalyst is a chemical substance. It is used to increase the rate of reaction. Do you know the warm water? The warm water is used to easily digest the elders, easily digest the infants. Because of warm water, one of the catalyst, it is used to easily digest our stomach contain food materials. The warm water also one of the catalyst. In the catalyst is a chemical substance. So do not react with the reactant. It initiate the rate of reaction, alter the rate of reaction, speed up the rate of equilibrium concentration known as a catalyst. So catalyst is a chemical substance. Do not react with the reactant itself undergo the chemical changes takes place known as a catalyst. Number of catalysts are there: positive catalyst, negative catalyst, auto catalyst, promoter, active center, catalytic poison. In the reduction catalyst, oxidation catalyst, neutral catalyst, number of catalysts are there. Simply catalyst is called chemical substance which used to increase the rate of reaction, which used to alter the rate of reaction without itself undergoing the chemical change. Do not react with the reactants. The catalyst do not react with the reactant. The catalyst it is used to increase the rate of reaction known as the catalyst. For example, in Haber process, preparation of ammonia, nitrogen gas N2 combined with 3 moles of hydrogen gas H2 to form of ammonia, 2 moles of NH3 ammonia in presence of iron metal. In this reaction, iron metal acts as a catalyst. Iron metal acts as a catalyst, main catalyst. In then another one, then potassium oxide K2O, aluminum oxide Al2O3 also as a catalyst used in small quantity. The catalyst substance or catalysts are used in small quantity. So small quantity of catalyst only needed. So what are the characteristics of catalyst means? Small quantity of catalyst only needed. Another one, In the catalyst remain unchanged in chemical composition and mass end of reactions. Remain unchanged mass and chemical composition at the end of reactions. Small quantity of catalyst needed. The catalyst do not alter the position of equilibrium. The catalyst only increase the rate of reactions. All catalysts have specific units of action. For example, iron metal used only in this reaction. Nickel metal can be used in the hydrogenation of a vegetable oil to form of vanaspati ghee. Vegetable oil combined with hydrogen to form of a vanaspati. Vanaspati ghee in presence of nickel metal. In contact process, in the process known as a Haber process. Habour, Haber process. Haber process. Another one, contact process. What is meaning of contact process? Sulfur dioxide, SO2, can combine with the oxygen O2. SO2 can combine with the oxygen O2 in presence of porous vanadium dioxide V2O5 to form sulfur dioxide SO3. Sulfur dioxide. The sulfur dioxide SO3 dissolved in water H2O to form sulfuric acid H2SO4 in the process known as a contact process. In contact process we can prepare the sulfuric acid. In Haber process we can prepare the ammonia. In contact process it is used for the preparation of sulfuric acid. In Haber process we can for the preparation of ammonia. Ammonia dissolved in water in form of urea. Urea can be used in fertilizer in agriculture. Urea. What is the meaning of urea? In the ammonia dissolved water. What is the formula of ammonia? NH3 ammonia. It dissolved water H2O to form NH2CO NH2. NH2CO NH2. So what is the formula of urea? NH2CO NH2. What is the formula of ammonia? NH3. What is the formula of water? H2O. So ammonia dissolved in water to form of urea. The ammonia can be obtained from Haber process. Okay, the ammonia can be prepared from the nitrogen can combine with hydrogen in presence of iron metal. In this reaction, iron metal it is a catalyst. Another one, the vegetable oil can combine with hydrogen. Hydrogenation of vegetable oil to form of vanaspati ghee in presence of nickel. In this reaction, iron metal is a catalyst. In this reaction, nickel is a catalyst. In this reaction, vanadium dioxide is a catalyst. Decomposition of potassium chloride. Potassium chloride, KClO3 is a decomposed form of potassium chloride, KCl plus oxygen gas is removed in presence of manganese dioxide, MnO2, manganese reaction. In the reaction, manganese dioxide as a catalyst. What is the formula of potassium chloride? KClO3. So KClO3 decomposed form of potassium chloride and oxygen gas. In this reaction, manganese dioxide, in the vanadium dioxide, nickel, iron metal act as a catalyst. The 6 topics. First one, contact in physical state. Another one, in the solution of reactant. Then electricity, light, heat, catalyst. The 6th factor it is used to determine the chemical changes reactions. Okay students, then today topic is over. In the next topic we will meet in next video. In the important question and assignment, I will give the question through WhatsApp. Do well. Thank you.